Okay, we're going to start here in Unit 7 with some cross sections and rotational solids. A little bit of vocab here first. A polyhedron is a three-dimensional figure whose surfaces are polygons. And a cross section is the intersection of a solid and a plane that slices through the solid rather. So we're going to identify some cross sections. I went ahead and just downloaded some pictures here. You don't have to try to draw all of these in. The main thought is that if you had these figures in like Play-Doh and we sliced them and pulled them apart and stamped them on a sheet of paper, what would we see? So in this case, we have a square pyramid that is intersected by a plane parallel to the base. And if we take a look at this picture here, you can see that if we were to slice this and pick up the point of that and stamp it on our page, we would end up with a square. Okay, so if we take a look here at our cone and we slice it perpendicular to the base, if I were to take this apart and stamp it, I would then have my triangle. And any way that you slice a sphere, no matter where you do, we're always going to end up with a circle. And if we were to slice a square pyramid perpendicular to the base, we would end up with a triangle. And you will find that to be true with any of our pyramids if you slice them vertically. So describe each cross section. If I take a cone and I slice it parallel to the base, I'm going to end up with that circle. Here I have a hexagonal pyramid, so if I slice it parallel to the base, I'm going to end up with a hexagon. The size will vary depending on where you slice it, but you will end up with that same shape as the base. And then here, you'll notice that we're slicing this at a little bit of an angle, and so what you'll end up with is a parallelogram whenever you cut that apart and stamp it down. Not a whole lot, just kind of gets you thinking outside the box a little bit. So rotating solids, if our rectangle shown below has dimensions of x by y, so in this case our dimensions are 3 by 4, and it is revolved around the y-axis. So if I spin this, think about a sticky note that is attached to a pencil. If I take the pencil vertically and I attach a sticky note to it off to the side and I spin my pencil, what I'm going to end up with is a cylinder. And that cylinder will have, in this case, a radius equal to 3 and a height equal to 4. Now, if I were to switch that around, and let's say here I am rotating about the y-axis, what happens if I rotate about the x-axis? So if I think about this the same way, but now I rotate it this direction, well, now the 3 is my height and the 4 is my radius. Okay, so what happens if we rotate this triangle? So same thing, if I want to rotate it about the given vertical line, what shape is formed and what would the 5 and 6 represent? So if I take this and rotate it around, think about my pencil being vertical and having a triangle extending out to the side of it. If I spin that, what it's going to form is a cone. And that cone is going to have a radius equal to 6, and the cone is going to have a height equal to 5. So same thing here, what figure is formed when rotating about the x-axis? So if I rotate it around this direction, again it's just a triangle, So as long as I rotate it vertically, think about this going up, down, up, down, up, down, up, down, then we are going to have a cone with a height that is equal to 4 and a radius that is equal to 5. But what happens if I spin it around the y-axis? Think about what this would form. If we use our rectangle, we know that we end up with a cylinder. So what we're going to have here is we're going to have a cylinder with a cone taken out of the middle of it. So if we spin this again, try to visualize that. If we spin it, we will have a cylinder that has had a cone taken out of it. So here, if I rotate this about the x-axis, this is a trapezoid here, and if I rotate it around the x-axis, it looks like it's going to form a cone, but the top of it is cut off. So it's a cone minus the point or the vertex. What we'll learn later is that this is called a frustum. New vocab word there for you. If I rotate it around the y-axis, the other direction, then I end up with a cylinder plus a cone. So just all things to consider. We'll actually use these a little bit later whenever we get into our volume and surface area, but as of right now, that's all that you need to know. All right, so surface area and volume of prisms and cylinders. Most of what we do right here is going to be a review. So you have drawn nets for a very long time. Remember, net is just the unfolded version of our three-dimensional figure. So if I want to draw a net for a cube, remember that a cube has 6 congruent sides. So I'm going to start here. We're just going to get it as close as we can to be in squares. So there are my 4 lateral faces, and then I need a box to close the top and a box to close the bottom. Now, since this is a cube, we need to go ahead and mark all of our sides to be congruent. And it has a side length of 6 units. This is not the only way to draw a cube. It is just one very common way and one that is fail-proof. What I would encourage you to do is to draw out the lateral faces first and then focus on where you need your bases to be. For a pentagonal prism, we're going to have a height of 5 units. Remember that this height is between the bases. Okay, so if that is our height between the bases, I'm going to have a lateral face for every side of my base. So here I'm going to have 5 rectangles along the edge. And I need a pentagon for the top and a pentagon for the bottom. So 1, 2, 3, 4, and the 5 at the bottom. 1, 2, 3, 4, and the 5th one at the bottom. Tells me that I have a height between the bases of 5 and a side length of 4. So whenever we mark our congruent sides, fold this together in your mind and think about what sides are going to hit where, and then all of the heights between the bases will be different. How can you use this information to find our lateral and our total surface area? If I find the area of each of those individual pieces and add them together, that will give me my lateral area and my surface area. So we're going to move past Euler's theorem and move down to some vocab. So a prism is a polyhedron with 2 congruent parallel bases. A prism is named for the shape of its bases. A prism has two bases. The rest of the faces are called our lateral faces. And the blank of a prism is the perpendicular segment that joins the planes of the bases. That will be our height. And that can also be called our altitude. The length of the altitude is called the height. In a right prism, the lateral faces are rectangles and a lateral edge is an altitude, or the height. The formula to find the lateral area of a right prism is PH, where P is the perimeter of the base. The formula to find the surface area of the total area of a right prism is PH plus 2B. And remember from probably 7th grade that big B is the area of your base. So the formula to find the volume of a prism is the area of the base times the height between the bases, so V equals BH. And now we're going to do some calculations. You guys know me. I like to have some routine, so what you'll find is that I will do the same routine over and over and over to keep organized. So the thing here is that with our lateral area, with a box, lateral area can vary. So what I'm going to do is I'm going to force us to use a base. So I want to use this orange side right here as a base so that everybody gets the same lateral area, and I will do that on a quiz or test as well. So I like to find three things whenever I first start out, before I ever plug anything into a formula. I like to find let's zoom in here, the perimeter of the base, the area of the base, and the height between the bases. If I can find those three things, I can then plug them straight into the formula. So the perimeter of my base is going to be 2 times 5 plus 2 times 6, which will give me 10 plus 12, 22. And the area of my base will be 5 times 6, which is 30. And the height between my bases is 7. So these are the numbers that we're going to use in our calculations. So to find our surface area, we're going to do PH plus 2B. And the first part of this will be our lateral area. So it'll be 22 times the height of 7 plus 2 times the area of one of the bases, which is 30. And if we plug all of that in, if I do 22 times 7, that is 154 plus 60. And I want you to leave it separate like that for a reason. That 154 will then be our lateral area. So our lateral area is 154, what are our units here, meters squared. And then for our total area, we're going to add 60 to that and get 214 meters squared. And then for our volume, we're going to do area of the base times the height between the bases. So that will be 30 times our height of 7, which will be 210 meters cubed. Same thing here. We're given our lateral area is 40 meters squared. And in this case, if I want to solve for the height, that is telling me that the base is my 6 by 4. So I'm looking here. I know that PH is equal to 40 for my lateral area. So if I do the perimeter of my base, which will be 6 plus 4 plus 6 plus 4 all the way around, that will give me 20 times my height is equal to 40. So my height is equal to 2 meters. And now we can find our total surface area. So I already know the 40. And now I need 2 times the big B. So the big B is going to be 6 times 4, which is 24. So 40 plus 48 will give me 88 meters squared. And for my volume, I'm going to do BH. So 24 times the height that I already just found of 2. So 48 meters cubed. All right, given our volume of 105 meters cubed, let's go back all the way to what a box is, right? A box is length times width times height. So if I know that that is 105, then that will be 7 times 5 times x. And if I do 105 divided by 35, I end up with an x of 3 meters. And now we can go in and find our lateral area and our surface area from there. So I'm going to leave those alone. I'm confident you guys can find those. We can go back to it later if you need to. So for our cube, let's talk about a shortened way to find volume of a cube. In a cube, all of the sides are the same. So if this one is x, then this one is x, and so is this one. So our shortened version for our volume is that x cubed is equal to 216. So if I want to uncube something, I'm going to take its cubed root. Now in your calculator, if you hit the math button, you can scroll down to the number 4 and get the cubed root and type in the 216, and that you get 6 for x. And then for my surface area, you can do the pH plus 2b, or I know that I have 6 of those faces that are 6 by 6. So that ends up with 216 as well. Now that is not always true. It just happens to be because everything is a 6. Your volume, sorry, that should be squared. Your volume will not always be equal to your surface area for a cube. So here's where we're going to bring in the new stuff that we just finished up doing in Unit 6. Find the lateral area, surface area, and volume of a regular pentagonal prism with a height of 4 and a base edge of 5. So again, I still want to focus on our 2 things, actually 3 things. Area of the base, perimeter of the base, and height between the bases. So the height is 4 centimeters, and I need to use this base edge of 5 to work with my pentagon. Remember that you don't have to draw out a pentagon. All we need is our triangle. So here's our triangle, and it tells me that I have a base edge of 5. So this is 2.5 here. And remember that we do our 360 divided by 2n. So in this case, 360 divided by 10. This angle is 36 degrees, which tells me that I'm going to have to use trig. But before we move into trig, let's go ahead and get our perimeter. So this is a pentagon. It has 5 sides with 5 lengths, with a measure of 5 centimeters for each side. So 5 times the 5 sides will give me 25 centimeters, and now we just need to go find the area of our pentagon, which is exactly what we finished doing in Unit 6. So we're going to go back to our AP over 2, and I need my apothem. So to find my apothem, I'm going to have to use tangent. So the tangent of 36 is equal to my opposite 2.5 over my adjacent, which is my apothem, and I'm going to plug this into my calculator as 2.5 divided by the tangent of 36. So make sure you're in degree mode. 2.5 divided by tangent 36 and I end up with an apothem of about 3.4 dot dot dot. And while it's there, let's go ahead and take that times our perimeter. So times our perimeter of 25, and I end up with 86.02, but then I have to divide it by 2 for my AP over 2. So my big B has a value of 43.01 dot 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 dot. And I am going to store that as big B because we're going to use it in multiple calculations. So now I have my big B, I have the perimeter of the base, I have the height between the bases, and we can go through and do our calculations. So I'm going to move over here for our surface area. This is going to be PH plus 2B, and I know that my perimeter has a value of 25. My height is 4 plus 2, and I'm going to leave it as a big B in parentheses because that's what I have it saved as. So this is 100 plus 2B. This 100 represents my lateral area. So I'm going to move back over here so we can keep everything together. Our lateral area will be 100 centimeters squared. And our surface area is going to be that 100 plus 2B. So 100 plus 2 alpha B Sorry, my calculator is being weird. And I end up with a total surface area of 186.02 centimeters squared. And for my volume, I'm going to do big B times H. So I'm going to use that 43.01 times my height of 4 and end up with 172.05 centimeters cubed. If a regular hexagonal prism has a base edge of 6 and a height of 8, find the lateral, total, and volume. All right, so I want to find three things again. Area of the base, perimeter of the base, and height between the bases. So this tells us that our height is 8. Our perimeter is going to be easy. It will be 6 for 6 sides, so 36. And now we just need to find the area of our base using AP over 2. So I'm going to start here with my triangle. I know that in my hexagon this is 30 degrees up here at the top. So this is my A and A square root 3 and 2A. And it tells me I have a base edge of 6. So remember that that 6 is all the way across. So this piece here is 3, which means that my apothem then is 3 square root 3. Now we're ready to do our big B. So if I do AP over 2, this gets me my apothem of 3 square root 3 times my perimeter of 36 over 2. I'm going to go ahead and cancel the 36 down to an 18. And then 3 times 18 will give us 54. And bring in the root 3. So my big B is 54 square root 3. And now we're ready to plug it into all of our pieces. So for our lateral area and surface area, this is where we're going to use our PH plus 2B. And our perimeter is going to be 36. Our height is 8 plus 2 times that 54 square root 3. All right, so the first part, 36 times 8, is going to give us 288. And this is meters. And I know I have that root 3 at the end, and it's not going to combine. So I'm going to go ahead and leave this as 288 plus 108 square root 3 meters squared. And for my volume, I'm going to do BH, which will be the 54 square root 3 times the height of 8. So 54 outsiders can mingle times 8 gets me 432 root 3 meters cubed. Okay, find the lateral area, total area, and volume of this equilateral triangular prism. Triangular prisms are some of the most common that are messed up. So again, organize your thoughts. We want the area of the base, we want the perimeter of the base, and we want the height between the bases. Our base is this 6 by 6 by 6 triangle. This is where I really like to use herons. So let's go ahead and find the area of our, the perimeter of our base. 6 plus 6 plus 6 is 18 inches. And for the area of that 6 by 6 by 6, remember that you can use herons. So we can do 6 plus 6 plus 6 over 2, which gives me 9. And then we'll do the square root of 9, and then 9 minus 6, 9 minus 6, 9 minus 6, so 3, 3, and 3. This 9 will break down into 3 times 3, so I bring out 1, 2 pairs of 3s as a 9, and I leave a root 3. So this is 9 square root 3. Remember, your trick also is half the side squared, and then attach the root 3. Your height will be this height between the bases, which is 8. And now it's just a matter of plugging things in. So for our lateral area, this is going to be our pH. So 18 times 8, which is 144 inches squared. So this is going to be, for our surface area, that 144 plus 2 of our bases, 9 root 3. So 144 plus 18 root 3 inches squared. And then for our volume, BH, so 9 root 3 times 8, which will be 72 square root 3 inches cubed. All right, I like to use the same exact formula for our cylinders, except our perimeter we just call circumference. You guys know how to use circumference, so you can use the expanded forms, or you can use the pH plus 2b. By expanded form, I mean 2 pi RH plus 2 pi R squared for the surface area, and the volume as pi R squared H. You're welcome to use those. It's easy to use those. And it's also easy to think of it as pH plus 2b. So either way you want to look at it is fine with me. For pH plus 2b, let's see, the perimeter of my base, which is the circumference, is 2 pi r, so 6 pi. The area of my base is pi r squared, so 9 pi, and the height between the bases is 8. So my lateral area, pH, 6 times 8, will give me 48 pi meters squared. And then pH plus 2b, this will give me my 48 pi plus 2 times 9 pi. So if I do 48 plus 18, that brings me to 66 pi meters squared. And for my volume, that will be 9 pi times the height of 8, so 72 pi meters squared. Same thing on number 2, just make sure that you split that into your radius of 9, okay? And last 2 here for today. Find the height of a right cylinder with a surface area of 198.8 square millimeters and a radius of 2.8. So I want you to put a big star next to these two. You will see 2 like this again. And it's just setting up an algebra equation. So if it gives us the surface area, I want to write out that my surface area formula is my pH plus 2b, and I want to expand that. So my surface area, the perimeter of a circle is 2 pi r, and then times the height, plus 2, the area of the base is pi r squared. And now we're just going to plug in what we know. So we know our surface area of 198.8, and we know our radius, and we're trying to find the height. So 2 pi times a radius of 2.8 times the height plus 2 pi times, make sure to put this in parentheses, 2.8 squared. Okay, what we want to do is we want to take this apart just like we would an algebra equation. So over here on the left-hand side, if we have 24 is equal to, I don't know, 2x plus 8, right? We subtract the 8 to get our 16, and then we divide by 2 to leave the x by itself. That's exactly what we're going to do over here with this. We are going to subtract this 2 pi times 2.8 squared. So we can go ahead and plug that into the calculator if you want to. 198.8 minus, and then put all this in parentheses just to get used to putting in parentheses. 2 times pi, parentheses, 2.8 squared, in the parentheses, And now we're at this 149.5 ... is equal to, I'm going to go ahead and do the 2.8 times 2, which is 5.6. So 5.6 pi times h. Now, here's the part where the calculator is only as good as what you put into it. I'm going to go back to having that 149.5 at the bottom of my calculator, and I want to divide by the 5.6 and the pi. Now, when we divide by 5.6 and the pi, we have got to put that in parentheses, or it will divide by 5.6 and then multiply the answer by 5. So divide by parentheses 5.6 and then second pi, and we end up with 8.5 and then a whole bunch of zeros. So 8.5 millimeters is our height. You've got to make sure that if you are taking apart that 149.5 and dividing it by everything on the bottom, you've got to group that together with those parentheses. Very, very, very common calculator mistake to make. If the volume of a cylinder is 18 pi meters and the height is 2, what is the total surface area? So anything having to deal with a circle, the key to unlocking it is the radius. So if I know the volume is area of the base times the height between the bases, which is pi r squared h. And I know my volume is 18 pi pi r squared, and the height is 2. So what I want to do is I want to divide by 2 pi. And in this case, I end up with r squared equal to 9. So my radius could be plus or minus 3, but since we're dealing with a radius that is a length, our radius is 3. Now we can use our radius and our height to find our total surface area. So our surface area is 2 pi rh plus 2 pi r squared. 2 pi times a radius of 3 times a height of 2 plus 2 pi times our radius squared. So I'm just going to go ahead and put in a 9. This is 2 times 3 is 6 times 2 is 12 pi plus 18 pi, which leaves us with 30 pi meters squared.